Hello, my name is Ethan Vandeloo, and this is my midterm presentation for AERO 4842 on my device called the cryo-vision. The mission objective is to design a scientific instrumentation that will be used on a mission to Jupiter's moon, Europa. Moving on to my project scope. My design focuses on creating an onboard image recognition system that helps the satellite detect surfaces and also nearby objects, enhancing its situational awareness and assisting maneuvers involved in landing and object avoidance. My goals are to design a system capable of machine learning. This will involve an onboard AI that can autonomously analyze visual data and adapt to Europa's environment. In turn, the system should be able to detect and classify surface features, ice fractures, and potential landing zones without relying on constant Earth communication. To do this, my design will require a computer-trained model that will be capable of interpreting terrain textures, lighting variations, and surface hazards, all under low light and radiation conditions as found on Europa. This will involve adding a camera to sense and capture objects. The camera will be able to continuously capture images of Europa's surface, feeding them to the onboard machine learning system for real-time recognition and mapping. So what is image recognition? It's essentially a form of computer vision, the ability for a computer to see and understand visual information, using machine learning and deep neural networks, same as a human brain, where the system can identify and classify objects in an image or a video. This is because the computer is trained on a large data set containing thousands or even millions of images. From this data, it learns to analyze pixel patterns and recognize visual features, like shapes, textures, or even motion. So how does this process work? First, we must capture the image using a camera or sensor on board the system. Next, we must pre-process this image. This is the data preparation stage, where raw images are cleaned, adjusted, and standardized before analysis. During this stage, lighting variations, for example, from Jupiter's reflected light, can be normalized, meaning the image is now clear and visible. Additionally, noise caused by cosmic radiation can also be filtered out. Now that the image is clear, we can now detect and classify these objects. After the neural network analyzes these images, it can now output the results. This can include labels, bounding boxes, or automated control actions based on what the system detects. Overall, the goal is to run real-time object detection using trained datasets, as you can see on the images on your slide, where I used a basic image recognition system to detect images such as scissors, orange, and my cat Pumpkin. Applications of my design are asteroid and space debris detection/tracking, surface feature identification, as previously mentioned, as well as precision landing for planetary exploration, and finally, the monitoring of mechanical systems or instruments. Now, to sum up all the theory I've mentioned, here is my design. First, we have the Raspberry Pi 5, which is used as the brain that contains the neural networks, enabling the image recognition after the camera module takes an image, while the IoT relay will control the power, essentially acting as a breaker, and can be used for other applications. For example, if an asteroid is detected in the mission path, the relay could switch on the power to the thrusters, maneuvering out of the asteroid's path. Likewise, the relay would be able to initiate the landing gear when the surface of Europa comes into vision. So what are my next design steps? My next design steps are to train my Raspberry Pi on space images, rather than your everyday objects as seen in my slides. This will further prove my device's capabilities. Next, I want to use my IoT relay to prove the concept of maneuvering using image recognition. Now enjoy this short video of my progress so far for this project.